Hello CS300 and welcome to my video on linked lists and how we use kind of a look ahead method in order to insert into our linked lists. So the first thing I want to go over is just why we even use linked lists. Why not use an array? So some advantages of linked lists are that you can insert or delete at the beginning of the linked lists in constant time. So for an array, we can access the elements in constant time, but in order to actually delete something at the beginning of an array, we may have to shift down all the other elements that come behind it. So that can be up to O of n time. Number two, it can be expanded in constant time. So if you recall, in order to make different copies of arrays, like that shallow copy versus deep copy, or just copying arrays in general, you need to actually duplicate that entire array, which means just like allocating more memory space and all that stuff. You can actually, for a linked list, you can just kind of like slowly add on as needed, so that's kind of nice. So the main disadvantage here, there's other ones as well, but the one that I wanted to talk about is that instead of having that constant access time, like with arrays that I mentioned earlier, we may have to search through the entire list to get to particular elements. So what that means is, let's say we have a whole linked list data structure here. Let's say I wanted to get to my data that holds node D. So these individual boxes I'm going to refer to as nodes. That's a very common thing in computer science. So we start off in our linked list and we have to go down to every single node in order to get to this last node here. So that would mean we'd have to go through every single element. And if we doubled the size of that, we would have to double the amount of elements that we go to. So that could be a lot of elements in the end. So essentially with a linked list, the data that we need for the entire linked list, so usually we have a linked list class, and that holds the current head of the linked list and oftentimes also the tail. The tail just means the last node. The head just refers to the first node. And then any nodes that come in between there, again, like I said, we have to iterate. You have to start from the head and go to the next, then the next, then the next, which means we have to maybe go through every element. And so that brings us to, for each individual node here, for example, node A, then it holds the data that it needs, and then in addition to that, every single node needs to have a next. So this node A's next is going to be referring to, of course, node B, and node B's next is node D. So what happens if we want to actually insert into our linked list data structure? So if we want to add a new node, for example, node D here, it's holding the data, or sorry, C, it's holding the data with C, and we'd probably want to put that right after node B, because let's just say we're maybe sorting our list in alphabetical order for some reason. Even if we weren't sorting it in a particular order, a lot of the time, if we're going to insert into a linked list, then we have to specify the node that in that list that we want to put it after. So you can kind of think of this in a way we're saying insert in my linked list after node B here. So basically we just want to make it so node C is put in between node B and node D. So we start off at our head. We need to iterate through, and so let's say if we were doing it alphabetically, or if we were doing it, we were trying to find a particular node. Either way, this is pretty simple. We start at the head, and that of course holds this node here. Okay? And so we see with node A that this is actually not the node that we want. and we want to see if this next node here is going to be the node that we want. Remember, we're looking for node B, okay? But we might not know that our next node is going to be the node that we want. So we kind of like want to look ahead. So we make that comparison, like, would node C come after node A? Yeah, of course it would. But before we move on, we want to be like, okay, let's look at the next and kind of like peek at what the next data is and if C would come before or after it. So if this was, I don't know, node F, the data was F instead of B, then C would want to be in between A and B. So we wouldn't want to move on yet. We still want to be on our first node here, node A. So we use this sort of look ahead method, and that is the whole reason why we have this next variable. It's sort of like, if you recall with stacks, how we had that peek method. It's sort of like peeking, but for linked lists. So we look at our next and we see that the data is B. Well, I mean, alphabetically, of course, B comes before C. So we actually are like, okay, so we're not going to be changing, it's not going to be in between these two, so we can actually move on to this next one and see if it'll be between these two. And so we do that, and now we're on this node, and we see that C comes after the alphabet in regards to B, but comes before the next data, D. So we now are like, okay, yeah, so these are the two nodes that we want to put C in between. But of course, we're still on our previous node here. We haven't actually moved on to this next node, but we know what it is because of this next here. So now, the first step we want to do while we're still on this node B is we want to update, or we want to save its next information in our new node. So before, you notice this didn't have any next information, but now we can save node B's old next and have them pointing to the same node. So now node B's next is D and node C's next is D. Then all we have to do is update node B's next to be node C. And now it's kind of just like it was just put in between node B and node D. So it looks more like this. So now we have A, B, C, and D. And so if we wanted to keep on adding more, that's kind of how you do it. You have to use that look ahead method in order to actually put them in between. Because if you think about it, if we had gone past node B here, then there's no way we could have gone and updated its next. We would have had to start over and get back to it. When I was a tutor last semester, I had a lot of people be very confused about that. I think it's a really important concept to grasp, so hopefully this helped with it. And then if you're wondering, also for doubly linked lists, it's a very similar thing. You have to make sure you're looking ahead from, same example here, from node B to node D. I think given the example that I just went through, this should be like, you should be able to do this on your own, kinda. But yeah, so essentially I have the steps laid out here. You update node C's next to be node D. So both B and C will be pointing to node D. And then you'll, of course, now node B will be pointing to node C. And then you'll update node D's previous to node C. If that was just a lot for you, I would encourage you to take the time to pause here and kind of walk through this on your own. It'll really make sure that you're understanding that concept of looking ahead when we're inserting into our linked list. So good luck on your next programs. Let me know if you need anything.